All right. Exercise 3ABC was transformations. I taught you how to do mapping notation. I taught you how to work out the equation of the image. And then I also taught you how to work out the sequence of transformation. What I didn't emphasize at that point was sometimes they will do the same thing, but in function notation. Okay? So here is exactly the same thing. It says determine the sequence of transformations for the graph. Unlike before in exercise 3E, you were given the original function and then you were given the new function, right? Now you've got f of x, which is the original function, but they're not telling you specifically what the new equation is. You can solve for that by simply reading the function notation here. This basically means 3 times whatever f of x is. Okay, so that ends up actually being a dilation of factor 3 from the x-axis. I might be speaking a bit fast for some of you here, but that is essentially you saying 3 times the y value. So have you been practicing 3D and 3E, knowing that that is equivalent to you doing this? Okay, so that's what the 3 does on the outside. Whatever's inside the brackets, that's your transformations for your x. Okay, so here, this is f of x. If I wrote f of 2x, this is like you substituting 2x into the equation, and that would give you 1 on 2x all squared. Now, again, if you've been practicing 3D, you would know when there's a 2 in front of x, this is a dilation of factor. What was that? Yes, well, it's from the y, but factor what? This is where you're going to be careful. Anything to do with the x's, it has to be. Okay, if you're unsure, it's the reciprocal. Instead of 2, it's factor half. Okay, and I'm going to show you how that works out. So what you're finding in here is when you're going through 3ABC, you'll find that towards the end, they start working in this notation. Okay, and the idea is that you need to get familiar with, well, how would you transform what you're used to in 3D and 3E in a function notation? So here's the example I'm going to show you. Let's start from here. So first determine, what does 3f of negative 2x plus 1 truly mean? Well, we know f of x is 1 on x squared. Whatever the x is, if I put a 1 here, then you put a 1 where the x is, so it'll be 1 squared there. If you put a 2 here, then it becomes 2 squared there. So when you say f of negative 2x plus 1, what you're saying is I'm replacing the x with negative 2x plus 1. What's the 3? Well, the 3 is timesing the function. This is the function, so you're doing 3 times 1 on x squared there. Okay, so if I put it all together, if f of x is 1 on x squared, then when you say negative 2f of negative 2x plus 1, what this is it's 1 over, instead of x squared, I now have negative 2x plus 1. Does that make sense? Because this is the function, that x there. If I told you to find f of 3, what you would have done is you would have done 1 over 3 squared. So all I'm doing is I'm just taking this inside the brackets and I'm replacing it with the x, just like you would have done here. Same idea. Okay? The second part is, well, you also have, and if you had to read the transformation, which will work soon, but here, when you say 3 f of negative 2x plus 1, so this is what negative 2x plus 1 looks like. When I'm putting a 3 in front, this just changes it to 3 times 1 over negative 2x plus 1 squared. Can you see what I'm doing there? So what they're trying to say at the end of the day, they're saying this is your original function, y equals 1 on x squared. You're mapping to y equals to 3 on negative 2x plus 1 squared. So this is exercise 3E. So that's what they've been showing you in 3E. But instead of saying that, they're using this. So it's a reading notation. It's being able to read what they're trying to say. Okay? Now, after you've done 3E a couple of times and 3D a couple of times, then you should be able to read backwards. You should be able to read this as dilation of factor 3 from the x-axis. I look at that and I can see that you're moving to the right by half. There's a reflection in the y-axis and a dilation of factor half from the y-axis. Okay, so that's the ability once you finish 3E and you practiced it well enough, you should be able to do that. But if you can't yet, this is how you do it. So, where should I do it? How did I set it up for you guys? I set it up as, yeah, okay. So this is your final equation. If it helps you, change that to y dash to help you, and then put an x dash there. We're going to work backwards. So remember the backwards, we're trying to get back to this one. Original y, original x. So if you want to go backwards so you can read the transformations the way I just did before, well, what is different about this one and that one? Well, this one has a 1, this one has a 3. So that 3 doesn't belong here. That must be belonging to the y transformation. But then whatever you're squaring, that's clearly dealing with the x's. So here I can say original x is equivalent to negative 2 times x dash plus 1. So I write that out. I say, okay, so therefore, one of the things I know is original x is equal to negative 2 times x dash plus 1. So I find it easiest when you're doing exercise 3E to work backwards and work with the x's first. Next one. To compare the y's, well, that 3 is a problem. I didn't have a 3 here. That's a 1. So the only way to get a 3 is I had to divide this side by 3. 3 divided by 3 cancels out to be 1. That means I have to divide this side by 3. So now I can compare it. I can say, yep, they both have a 1. They're both something squared. And these y's, that must mean then I can now say original y is equivalent to y dash on 3. See that? Now what I taught you last session is that what we're trying to find is we're trying to figure out x dash, y dash. Because if you know what x dash is equal to, you can read the transformation, and then you can read the transformation for y. So here, I need to rearrange the equation to get x dash, because I want to know what x dash equals to. So here, let's do it. Minus 1 on both sides. That cancels out. I get original x minus 1 is equal to negative 2 x dash. I'm just going to move this down a bit so you get a bit of space. And then from here, to get x dash, I need to divide both sides by negative 2. Divide by negative 2. That cancels out. And so what do you get? Therefore, x dash is equivalent to x minus 1 divided by negative 2. If you split up the fraction, that's essentially the same thing as saying negative half of x and then plus half. I'm just splitting up the fraction, yeah? Double negatives is positive half, and then 1 divided by negative 2 is negative half x. Okay, so I just split it up. So that means your transformation is this, negative half x plus half. Whilst the y, let's look at the y transformation. You want y dash? Get rid of that, divide 3. Here we go. I'm going to times 3 to both sides. And you get y dash is equal to 3 times original y. So what does that mean? Exactly what I told you before. If you were to read this now, this is what I was saying, that 3 was a dilation from the x-axis, factor 3. This one was moving to half to the right, reflection in the y-axis, and then I said it's a dilation factor half. And that's what I was saying. Being careful over time, you would be able to read these transformations here, and you'll be able to read the outside as well. So usually anything on the outside is to do with y, anything inside the brackets is to do with x. The x one is confusing because it's usually the opposite of what you see there. Okay?
Just a general question.
Yeah.
Is there any use for the CAS when doing transformations? Like exam 2 questions.
I think there would be. I haven't used the CAS, especially when I'm teaching this part. I know that back then we had matrix transformations, and that's where we used a bit more of a CAS. I have seen students do the solving part. So you know how I'm doing all those solving bits here? So they've solved it by doing f of y, and then it just rearranges it for them. So that's what I've seen.
Pretty simple. You can't just give it a transformation function.
Not that I am aware of. Do you know one?
I can't find anything. I'm having a look at the.
All right. If you do, let me know. I'm not familiar with those ones. Usually it's often knowing the theory, and then you look at the equation and you're meant to be able to read it from there. So that's the function notation part. So if this is tricky, don't worry, next week I'm going to reteach this part again, but I just thought for those who weren't sure about this question, I just clarify what that f of 3x might mean. Okay? It is. I was going to try to just pump through it, but given that this one took a bit longer than I thought, I might just do f today. Yeah. All right, team, let's have a look at f then. So on your sheet, which is f today, let's stop this.